Hello and welcome to our discussion on independent versus dependent variables. This is an important discussion because it really relates to the kinds of ways that we use variables as we're moving forward and talking about study design. So I wanted to spend a few minutes talking about this before we launch into the different study designs that we will be looking at. First of all, before we get started, let's talk about some other names that these variables might have. Traditionally, statisticians talk about these as independent versus dependent variables, but they can also be called predictors and outcomes. This is a dependent variable and an independent variable. They can also be called exposure and disease. We sometimes also call this, like if we have a treatment and an outcome, we might think about an intervention. Anything that we think is going to affect something else would be considered over here on the independent variable side. And the thing that it affects is over here on the dependent side. Now that implies a certain level of causation between the independent and dependent variable. In other words, what we're saying is this dependent variable depends on the independent variable. So if we know something about the independent variable, then we can find things out about how the dependent variable depends on that. So that's just a lot of words to say that we do have variables that are more like predictors, and we have other variables that are more like outcomes. Now, for the purposes of most of the discussions that I'll have, I'll be referring mostly to exposure and disease because I think those are very intuitive in terms of thinking about I got exposed to something and it caused a certain disease. But it doesn't always have to be that way. It could be that I'm giving somebody a treatment for a disease, or I have some sort of intervention and I want to decrease that other disease. So independent and dependent is just a very generic, non-judgmental way of talking about it, but it's also very abstract. So I'm going to be using the words exposure and disease when I talk about independent and dependent variables. Now, one of the most common ways that we use these kinds of variables is in something called a 2x2 table. So let me go ahead and draw a 2x2 table right here for us to look at while I'm having this little talk. And by convention, most epidemiologists, statisticians will put the exposure as the row variable. And this would be yes, and this would be no. And most statisticians then put the disease as the column variable. So this would also be yes and no. And this is the conventional way of doing it. And the thing that you'll notice about this is that our yes, yes, somebody got exposed and they have disease is in this top left corner of the 2x2 table. Now, one thing to mention is that in this particular situation, what we've done is for both disease and exposure, we have put them on the nominal scale, right? Having a yes-no is really nominal. It's not ordinal or scale. However, we do measure many things either ordinally or on a scale variable. So this is very much a simplification. But for the purposes of having a discussion about different study designs, it's very helpful to think about it this way. So recognize that these could be ordinal or scale variables, but for now we're going to just consider them to be both nominal or dichotomous. Now, the thing then that we need to think about in terms of this table, we have our yes exposure, this is our exposure of interest, and our yes disease in this top left corner. And so these are all of the people who have disease and they were exposed to that particular thing. But let's step back for just a minute and fill in some of the other information as well. If we were to only think about whether a person has disease or not, in the past, we've called these cases and non-cases. Do you remember using that terminology before? Hopefully, if we were to ignore this whole top of the table, let's say we ignore everything about the exposure and we're just focused down here on cases versus non-cases. If you remember, prevalence is equal to cases over cases plus non-cases. In other words, our total population that we have at that particular given time. So that's our prevalence. Now, so this bottom part, the cases plus non-cases, could be called our total. So here we have cases plus non-cases equals our total. And in fact, over here in this little cell, right about here, is usually where we have our, what I call the total number of people in that particular study. Another way of thinking about this particular table is by exposure. Here, if we think of the total at this point, this would be everyone who is exposed. And here on the next line down would be everyone who is not exposed. So we have our marginal totals for the marginal totals for the columns are cases and non-cases. Marginal totals for the rows are exposed and not exposed. And so these would all be replaced by numbers. And what that means is that this top left box then is our important thing, what it is that we're wondering about. Does this particular exposure lead to or contribute to or be associated with this particular disease? And so whenever you're setting up the table, it's important to put that particular group in your top left, whatever it is that is your focus of interest. Now, a word about test-taking situations. Almost always they will do something that changes this, because what they want to test is your knowledge, not whether you can memorize A, B, C, and D. So they will trade the yes and no category, or they will trade the exposures, yes and no. They'll put no on the top and yes on the bottom. And so what you need to do then is you need to find wherever that new yes, yes category that is your focus of interest, and be able to either readjust it in your mind or redraw that table so that it is in a format that you're used to. So if we were to think then about filling in the rest of these cells, this particular cell over here on the top right is those who are exposed but do not have disease. The bottom left is the people who were not exposed but they did get disease. And then the bottom right is those who were not exposed and did not get the disease. So that is just kind of a big bird's eye view of the 2x2 table and how that relates back to, say, prevalence. Now, there's a big if with this particular prevalence, and we'll see this immediately when we look at some of our study designs coming up. This is prevalence only if this total right here, the total, is a representative sample of our entire population. In other words, we have good denominator data, because here's our denominator. This cases plus non-cases is our denominator for this particular relationship. And if we've somehow manipulated the relationship between cases and non-cases, then that is no longer a good way to measure the prevalence. So that is the relationship then between independent, here's our exposure, independent variable, and dependent variable, or exposure and disease. This is kind of our standard way of drawing that. One final thing that I do want to come back to, which is I mentioned that these independent and dependent variables do not have to be nominal. Sometimes they are both scale. So let me show you an example of what that would look like. If we have a predictor variable, and let me see if I can make this be into kind of big dots. Many of you have probably seen what I'm drawing right now, and this is called a scatter plot or a scatter diagram. And what this is instead of being a yes-no relationship between exposure, yes-no, and disease, yes-no, this now is on a continuum. And by convention, we typically put exposure along a continuum on the x-axis, and we put our disease or our outcome by convention on the y-axis. And so here's an example of doing the same kind of thing, except now we're using scale variables and we're looking at that same kind of relationship between. So some people have asked, you know, here we have our 2x2 table, but then the textbook shows these scatter plots. How is that related? And so this just shows kind of how we would by convention do that if they're either nominal or if they are scale. There are many, many different ways of showing these kinds of relationships. These are not the only two, but they are two of the very common ones. And so I wanted to make sure that you kind of grasped that relationship between independent versus dependent variables before we move on to talk about the different study designs. Thank you for joining me for that discussion.